Hello everyone. Finally, we get to the last chapter of the class. So the last chapter is about regression model. So this is actually the regression model is the ultimate goal of this course. The reason why economic statistics is required for econ majors is because you need to understand how regression works to learn advanced courses like labor economics, industrial organization, industrial international trade, like banking, like health, environmental. All these all these fields need data work, and their data work at least like 90% is using like the regression model. So the regression model is the workhorse, and so everything we have learned up to here or to learn the regression model. So let me start. So regression analysis is, simply speaking, is a prediction. We'd like to predict, we'd like to explain a variable of our interest, right? Again, outcome. And like to explain, to predict that, we need to utilize other variables, right? So using other variables, we'd like to explain the outcome. And to do that, well, like we have to understand all the methods we learned up to here, like estimation and hypothesis testing are the applied to the regression model. And so we are going to learn the very basic regression model in this chapter. And of course, there are a lot of variations of the regression model used in practice, but this is just a very basic regression models. So let me start with a very simple question first. You may remember what was the marginal cost and the fixed cost. I believe you learned them from the very first economics class, right? So like introductory microeconomics maybe. So simply suppose that like your marginal cost is $2 per unit, and your fixed cost is $10 per unit. When you produce another unit, like you are going to get, you have to cost $2 more. And then given those marginal costs and fixed costs, what is a wrong statement among these? When you produce 5, the total cost is 20. When you produce one more unit, the total cost increases by $2. When you produce 10 units, the average cost is 3. And if your budget is $48, then you can produce up to 15 units. What is wrong? Right? It's really simple. It's as simple as it is. Like it's an introductory economics question. The answer is all are correct, right? So I just wanted to show you the intention. My intention was that I just wanted to show you, if you know these two numbers, you can answer a lot of questions. You can calculate these things, right? Right. So that's what you learned in microeconomics, right? So the microeconomics is to find the optimal production or optimal consumption and how they make an equilibrium in the market. That's microeconomics, right? Roughly speaking. So you learned how to find the optimal when you know those parameters, when you know the marginal cost and the fixed cost, right? If you know them, you can actually, it's pretty simple algebra, right? Right. So that's what you learned in microeconomics. And then based on that, I said you choose your production, and then based on that, your price is determined in the market. So that's how the market works. But what we are doing in this course is the other way. We, in practice, in the reality, we don't observe what is the cost parameters. Well, we don't know the cost parameters. What is the when I buy something? So when you buy a smartphone, I don't know how much is its marginal cost, and I don't know how much is the average cost when Apple makes iPads or iPhones. I don't know the cost. Even the CEO, even the leader of that firm may not know exactly how much is the marginal cost and how much is the fixed cost, right? So instead, I know what is the price. And we can see how many iPhones are sold. What we observe is the quantity and the price, not the cost parameters, right? So we are going the other way. In microeconomics, we assumed cost parameters, and from there, we derived the optimal and the equilibrium price and quantity. But in reality, we go the other way. We observe the price and quantity, but we don't know the cost parameters. So we are going the other way. That is data work, right? We have data about price and quantity, and then I'd like to know the cost parameters, right? And it is not as simple as microeconomics because we need to think about many random errors or and like mistakes, like say accounting errors, errors in production, and inventories or like overproduction, and a lot of things happen in reality different from the textbook microeconomics textbook. So in your data work, we have to think about all these things together, and that's what we are doing. And even as I said, even Tim Cook does not know what is the exact fixed cost and marginal cost. Maybe he will need to estimate it like based on like data. Like he would have more data than we have, but that's what we are going to do in data work in general. Economic data analysis complements the theory like microeconomics, macroeconomics. Okay, so this is exactly the previous question. You can turn the question, you can flip the question, and we would like to answer these. We'd like to know these, but to do that, to answer these questions, we need to know these two numbers. That's what we have in reality, the actual problem in reality. So what we are going to answer these questions. Like actually, your question is when you produce 5 units, what is the total cost? When you produce one more unit, how much does the cost increase? What uh, what is the loss if you do not produce anything? And you want to make an average cost less than $3. How much do you have to produce? If your budget constraint is $40, how much can you produce? These kind of questions is more natural, realistic questions, and this question is literally textbook exam question. If you have these cost functions, then what is true? Something like that. This is pretty unrealistic, or theoretical questions. Okay. So then, suppose that you have a monthly cost and output, right? So suppose that your output is measured in tons and your cost is measured in $1,000. And I observe last year's monthly output and cost, right? So in January, you produced 2 tons of the product, but it cost $15,000, right? In February, you produced a little more, but your cost is the same. In March, you produced a little more, then your cost increased now. So in this way, I assume I observe like outputs and costs. Of course, real data would be much bigger and there would be more variables. But let's start from the very simple model, like a textbook model of marginal cost and fixed cost, right? So you observe 12 outputs and 12 costs, and they are matched, right? So you observe actually 12 monthly data, and each month you observe 2 variables. So basically the sample size is 12, you observe 2 variables, okay? And then on a scatter plot, this is what you get. As the output increases, horizontal axis is output. As output increases, cost also increases, of course, right? And your observations are these 12 dots. We observe 12 dots, and you see a clear straight line because right, I made the data look like a straight line. So what we are going to do is we are going to set up a model like this. It is a linear regression model. We call this equation a linear regression. So I assume that y is the total cost. X is your output. So if you produce X units, then your total cost will be beta 0 plus beta 1x. That is your total cost. But on top of that, I allow some kind of error. I don't know what is an error. Like that's the definition of error. Some error happens. Like sometimes, like it's the productivity is higher this month than the last month. I don't know why, but sometimes some mistakes were made, so we lost some materials, something like that, or just simply accounting errors, or circumstances change, so your productivity may change. So all of these things, except for the production amount, is included in the error term, right? All those things are included in the error. So then uh, beta 0, beta 0 is the fixed cost because it does not depend on x. So even if x increases, from like 1 to 2, beta 0 is not affected. So always you add beta 0 to your cost, no matter how much you produce. But beta 1 is the marginal cost because when you increase x, the production, by 1 unit, your cost increases by beta 1, right? Exactly, that's what the marginal cost means. That's the marginal cost. So in this way, you we are going to estimate, we are going to assume that the total cost is generated this way, and we observe. Now here you need to think about what is observed and what not, and what is random and what not, and what you estimate and what not. Like what you observe is the cost, monthly cost and monthly output, as you just saw here, right? You observe 12 outputs and 12 costs by month. So they are observed and they are random. X and Y are random because each month, 1 month is one experiment, right? Observational unit is 1 month. So each month the cost and output may be different, right? So they are random. X and Y are observed and random. But beta 0 and beta 1 are unknown. Like marginal cost and fixed cost are what we would like to know, what we like to estimate. So they are unknown. But also they are constant, they are not random. We assume that like over 12 months, the cost does not change. That is underlying assumption. If the cost changes, then we cannot estimate what will be the cost next year based on the past data, because next year the cost will be different. So basic underlying assumption is that the cost does not change over time. So beta 0 and beta 1 are constant. It's not random. They are not random. At the same time, they are unknown. So we would like to estimate them. Beta are what we are going to estimate, right? And finally, epsilon. It's the error term. So it is an error. So it is unknown. I don't know how much error happened in that month, right? So it is error, and also it is random. So last month error could be different from next month error. So each month, like the error can be negative, positive, can be 0, can be big or large, like small, like it can be different. So it's random. So even though the Bayesian model is pretty straightforward and pretty simple, there are many details you need to understand. So and in the end, we would like to estimate those two parameters, beta 0 and beta 1, using observations on X and Y. That's what we are doing in regression. Okay. Let me give you more examples from economics. So earlier I gave you cost function example, the relationship between output cost and output can be applied to regression model, and like demand and supply functions can be approximated to a regression model. Like say, quantity demanded or quantity supplied is a function of price. If price is high, demand will decrease, so beta 1 will be low, negative. Or if price is high, then the supply will increase, right? So beta 1 will be positive for the supply function. So supply function increases and demand function decreases. So in this case, and epsilon is on error term. So the market could be a little bit inefficient or a little bit off the equilibrium. So that can happen. There can be something in the supply chain or demand trend. So all these things other than price is included in epsilon. And in this model, actually the actual estimation of demand and supply functions is more complicated, not as simple as this. Of course, it uses more data, more variables, and more techniques. But just given this simple model, in many cases, we are interested in beta 1. Beta 1 captures the elasticity, like when price increases by $1 or 1%, how much quantity increases or decreases, right? So that's exactly the definition of elasticity, and it is very useful to find out the optimal monopoly price and optimal taxation and surplus, like consumer surplus and producer surplus. When you calculate those things, you need to estimate beta 1 first. So that is a pretty important parameter in microeconomics. Okay, and another example from macroeconomics. Keynesian, Keynesian consumption function assumes that your consumption, household consumption, is a function of income, right? Of course, if you earn more income, then you are going to consume more. That is pretty straightforward. But Keynes thought that it is not 100%, right? So first, there is beta 0. Even if your income is 0, you need to consume the basic things, like you have to pay rent, you have to pay, electricity and electricity, water, these bills, utilities must be paid, even if your income is 0. That is we call autonomous consumption, right? So must pay is beta 0. And when your income increases by $1, your consumption increases by beta 1, right? So for example, if I get say $1,000 today for no reason, just a surprise bonus, I get $1,000 as a bonus today, then I'm not going to consume all of them. I may have a nice dinner, or I may do something, but I'm not going to consume up all $1,000. So beta 1, my consumption does not increase as much as 1,000. But maybe I can consume several $100s, but not 100%. We call that ratio as the marginal propensity to consume, right? When your income increases by a certain by 1, how much your consumption increases, that is marginal propensity to consume. So in macroeconomics, beta 1 captures literally propensity to consume. So this is pretty important when you determine the how much the economy is circulating, how fast circulation goes in economy. So it determines the effect of government spending. If you have heard about multiplier effect, which is the total effect of government spending, how much it stimulates the whole economy, that is based on the marginal propensity to consume, something like that. So anyhow, in the most frontier, actual real research assumes more complicated model than this. But as an example, this is just a basic model to estimate them. Like, of course, we, like economists, add more assumptions, more variables, more data, and more techniques to estimate those parameters. But to their core, this is what they are doing. Okay, so regression is pretty important in many economics, literally. Like it's 90% of economic data analysis is based on some kind of regression model. Okay, thank you for watching. This was a brief introduction to regression model and how we can understand regression in economics. Okay, in the next video, I will come back to statistics and set up what we are going to do and how we can estimate that and what we can do after the estimation. Thank you for watching. See you later.